Section 6.1 is angles and their measurement, so I would pause the video and write down these notes. So remember, an angle is two rays that start with a common vertex at the starting point here. This side here, we call this the initial side. For most of the things we're doing here, it's going to be sitting on the positive x-axis with the vertex at the origin, and then the other side we call the terminal side. If you measure in a counterclockwise rotation, that is the positive direction. If you go clockwise, that is the negative direction. A lot of times you're going to see this notation here, this theta. It's the Greek letter theta. We use that to represent angle measurements. A quadrantal angle is an angle whose terminal side lives on one of the axes. So for instance, 0 degrees would just be flat, 90 degrees would be coming up the positive y-axis, 180, 270, so on and so forth. So in this class, we're going to start talking about a new type of angle measurement other than degrees. We're going to be talking about this angle measurement called radians. So one revolution around a circle, which in the past we've always called 360 degrees, that's the same thing as 2 pi radians. Okay, so we're going to start using this. This is nice because it's a non-unit. When we use it a lot, pretty much moving forward, we're going to be using radians exclusively. So if 2 pi radians is 360 degrees, then pi radians is the same thing as 180 degrees. So we can use this to help us convert between it. So I always use this dimensional analysis. So 60 degrees, if we want to convert it to radians, pi radians is the same thing as 180 degrees. So your degree symbols, your unit of degrees cancels out. You can also do some algebraic canceling here. There are 3 60s and 180. So 60 degrees is the same thing as pi over 3 radians. So go ahead and pause the video and convert negative 45 degrees into radians. So negative 45 degrees multiplied by pi over 180 degrees to cancel out degrees, and you end up with negative pi over 4. You notice that I did not write a unit here. That's not a mistake. Radians are what we call a non-unit, so you don't actually have to write radians. If there is no unit written, then we assume it's radians. So negative pi over 4, we assume that's radians. So whenever you mean degrees, you have to write the degree symbol. So we can go the other direction if we want to convert from radians to degrees. So we have pi over 6 radians, and we want to convert it into degrees. So instead of multiplying by pi radians over 180 degrees, we're going to flip that. We want degrees on top, so we're going to multiply by 180 degrees divided by pi. So if you multiply this together, the pi's cancel. 6 goes into 180 30 times, so pi over 6 radians is the same thing as 30 degrees. Let's go ahead and pause the video and convert negative 7 pi over 3 into degrees. So multiply negative 7 pi over 3 by 180 degrees divided by pi. Pi's cancel, and you end up with negative 420 degrees. 6.2 is trig functions and the unit circle. So here are the main angles in the first quadrant that we look at. So 0 degrees is the same thing as 0 radians. 30 degrees is the same thing as pi over 6. Pi over 4, 45. Pi over 3 is 60. Pi over 2, 90. So then in the next slide, we're going to look at the entire up to 360 degrees. So this is a unit circle. Go ahead and pause the video and write all this down, and then I'll explain it. So this is called a unit circle because it is a circle that has a radius of length 1. So anywhere on here, your radius is 1, and it has a center at the origin. So the blue are the angles in degrees. So starting at this initial side here where I kind of drew this green line, if I draw an angle out to here, that would be a 45-degree angle. If I drew an angle starting here all the way down out to here, it would be a 240-degree angle. The red are the radian measurements at those same locations. And the purple are the xy coordinates. So at this point on the circle, that makes a 30-degree angle with the positive x-axis. The coordinates are root 3 over 2, 1/2. So this is something that's going to have to be memorized. If this is not memorized, it's going to make the next couple chapters very, very difficult, especially the radian measurements and the the coordinates. Okay, but there's a pattern to it. So starting at 0 is on your x-axis, and the ones closest to your x-axis have denominators of 6, the ones in the middle have denominators of 4, and the ones closest to your y-axis have denominators of 3. The first quadrant, the numerators are all just pi. The second quadrant, the numerators are 1 less than the degree. The third quadrant, the numerators are 1 more than the degree. And the fourth quadrant, there's 2 ways you can think about it. Either add across, so 2 plus 3 is 5, 3 plus 4 is 7, or it's twice the denominator minus 1. 2 times 3 is 6, minus 1 is 5. The x and y coordinates don't change, so all of the 6's are root 3 over 2, 1/2. All of the 4's are root 2 over 2, root 2 over 2. All of the 3's are 1/2 root 3 over 2. Notice these are the same, they are just flipped of each other. All the quadrantal angles are 0, 1, or 1, 0. The only difference is we are signs. So in the first quadrant, x and y are both positive. In the second quadrant, you have negative x, positive y. In the third quadrant, they're both negative. And the fourth quadrant, they're positive, negative. Notice here, you have 0 radians, or 0 degrees, and then the full circle would be 360 degrees, or 2 pi. So there's two angles on this side over here. So we're going to be working on these throughout the entire chapter, so make sure you start looking at this. Have this on a separate piece of paper, somewhere easy to see. So now we're going to talk about the 6 trig functions. The 6 trig functions are sine, cosine, tangent, cotangent, secant, and cosecant. So if you have a circle similar to your unit circle, but it could be any radius r, and you pick a point somewhere on that circle so that it makes, if you draw the radius, it makes an angle theta with the positive x-axis, then there's an x-coordinate of x and a y-coordinate of y. So if you kind of create this right triangle, that means your horizontal distance is x and your vertical distance is y. So then the sine of this angle is y over r. The cosine of this angle is the ratio x over r. Tangent is y over x. Cotangent is the inverse of that, so x over y. Secant is the inverse of cosine, so r over x, and cosecant is the inverse of sine, so r over y. If you're on the unit circle, then all of your radii would be 1. So here's an example. It says P is xy. In this case, it's 1/2 negative root 3 over 2, and it's a point on the unit circle. So the fact that they're telling us this is the unit circle, they're trying to tell us that r is equal to 1. And it corresponds to some angle t. So I have kind of a little picture here. It's down in the fourth quadrant. Here's angle t, or you could have also say this big angle is angle t. And we want to find the exact values of the 6 trig functions for angle t. So we're not actually solving for the angle, we're just finding the ratios. So sine is your y-coordinate divided by your radius. So our y-coordinate is negative root 3 over 2, and I'm going to divide that by my radius, which is 1. So sine of t is negative root 3 over 2. So go ahead and pause the video and find the other 5 trig functions of angle t. So cosine is the x-coordinate divided by the radius, so you end up with 1/2 divided by 1, which is 1/2. Tangent is the y-coordinate divided by the x-coordinate, so negative root 3 over 2 over 1/2. Your over 2's cancel, you end up with just negative root 3 over 1, or negative root 3. Cotangent is your x divided by your y, so you could have done 1/2 divided by negative root 3 over 2, or you could recognize that it's just the flipped of tangent, so it would just be negative 1 over root 3. This is a perfectly acceptable answer. Just know sometimes you'll see this with the denominator being rationalized, so multiplying this by a root 3 over root 3, so it's the same thing as negative root 3 over 3. These cancel, and so you don't have a square root in the denominator. This is perfectly acceptable, but you will see this sometimes. Secant is your r divided by your x, so 1 over 1/2, or it's your cosine flipped over, so 2 over 1, which is 2. Cosecant is r divided by y, so 1 divided by negative root 3 over 2, or just flip your sine over, again, negative 2 over root 3, perfectly acceptable answer, but you will sometimes see this rationalized as negative 2 root 3 over 3. So this is just knowing all of your ratios and filling in the pieces that they give you. So in this example, we want to find the exact value of all 6 trig functions given the angle without using a calculator. If they are not defined, then say undefined. So here on this one, 5 pi over 6, that's one of the ones that's on your unit circle. So when I see an angle that I recognize on the unit circle, I'm going to assume it's on the unit circle. So I'm going to assume that my radius is equal to 1. And then if you look at your x and y coordinates for 5 pi over 6, that would be negative root 3 over 2, comma 1/2. It's an over 6, so I know it's root 3 over 2, 1/2, and then 5 over 6 is second quadrant, so x is negative. So now you have all this information. Find your 6 trig functions like we did in the previous example. So given all this information, sine is y over r. Since r is 1, it's just going to be your y-coordinate, which is 1/2. Cosine of 5 pi over 6 is x over r. Again, r is 1, so it's just going to be your x-coordinate of negative root 3 over 2. Tangent is y over x, so 1/2 divided by negative root 3 over 2. Your over 2's cancel, you're left with just negative 1 over root 3. Cotangent is x over y, or it's the reciprocal of tangent, so negative root 3. Secant is r over x, or the reciprocal of cosine, so negative 2 over root 3. And cosecant is r over y, or the reciprocal of sine, which is just 2. So now to do the same thing, but with theta to be 4 pi over 3. Find that on your unit circle, find its x and y coordinates, and then find the 6 trig functions. So if you find 4 pi over 3 on your unit circle, which means the radius is 1, then your x coordinate is negative 1/2, your y coordinate is negative 3/2, so sine would be root 3 over 2. Sine would be negative root 3 over 2. Cosine of 4 pi over 3 is negative 1/2. Tangent of 4 pi over 3 is root 3. Cotangent of 4 pi over 3 is 1 over root 3. Secant of 4 pi over 3 is negative 2. And cosecant of 4 pi over 3 is negative 2 over root 3. So this is the same question, but now our theta is 5 pi. So if you look at your unit circle, you're not going to see 5 pi on it, but it is actually on the unit circle. So if you think about starting at the positive x-axis, okay, remember this is 0, and this is pi, and then if you go around again, this is 2 pi. So if you start here, you go here, you're at 1 pi. Keep going, one full circle is 2 pi. If you keep rotating, now you're at 3 pi. If you rotate some more, now you're at 4 pi. So think about, a 720. It means you've gone around the circle twice, 2 360s. That's the same thing as 4 pi. So if you keep going again, 5 pi is in the same location as 1 pi. So since 5 pi is in the same location as 1 pi, it's going to have the same x and y coordinates. So it's going to have the x and y coordinate of negative 1, 0, and it's going to have a radius of 1. So if it looks like something that's sort of on the unit circle but maybe bigger, or if it's negative, that means it's going down instead of going up, you go the same distance but you just keep going. So now you have your variables. Go ahead and try this one. So using the x and y coordinates of negative 1, 0 and the radius of 1, sine on your unit circle is just your y coordinate, so it would just be 0. Cosine on the unit circle is just your x coordinate, so negative 1. Tangent is y divided by x, so 0 divided by negative 1, which is just 0. Cotangent is x divided by y, so negative 1 divided by 0. We cannot divide by 0, so this would be undefined. There is no cotangent of 5 pi. Secant of 5 pi is the reciprocal of cosine, or 1 over negative 1, which is negative 1. Cosecant of 5 pi is the reciprocal of sine, or the radius 1 divided by the y coordinate of 0. We cannot divide by 0, so this would also be undefined. So on this one, they're giving us a point 5, negative 12. That's on the terminal side of this angle theta. So again, your angle theta could be this big angle here, or it could just be the negative angle down here. And they're telling us it's 5, negative 12. So if we create this little right triangle here, we know the x distance is 5 and the y distance is negative 12. But this one, they don't tell us that it's on the unit circle. So therefore, we cannot assume that our radius is equal to 1. So first thing we need to do is find the radius. So go ahead and pause the video and use the fact that this is a right triangle to find that value of your radius. So this is a 5, 12, 13 right triangle. So when you find that, you end up with your radius to be 13. So now you have your x and y coordinates and you have your radius. Go ahead and pause the video and find the exact value of all 6 trig functions of theta. So again, sine is y over r. Now your radius is not 1, so it's going to be negative 12 over 13. Cosine of theta is x over r, so 5 over 13. Tangent of theta is y over x, so negative 12 over 5. Cotangent of theta is x over y, or the reciprocal of tangent, so negative 5 over 12. Secant is r over x, or the reciprocal of cosine, so 13 over 5. And cosecant is r over y, or the reciprocal of sine, so negative 13 over 12. So this has been an introduction to radians, the unit circle, and the 6 trig functions.